Okay, so obviously there was a camera malfunction. So I'm going to try and pick up where we left off, and I'm going to try and put the two videos together. So anyway, you're going to see me, different clothes, probably different lighting and everything. But anyway, so we were in the middle of this problem when my camera died. Okay, so the next step that we're going to do, I have already done power to power, so I distributed this exponent to everything inside. Now what I'm going to do is I'm going to use the quotient rule, so I'm going to basically combine any like terms. So like terms would be the x's and the z's, and I'm just going to do this out to the side here so that we don't have to rewrite everything. So x, we have quotient rule would be one exponent minus the other, numerator exponent minus the denominator exponent. So we have x, we have negative 12 minus a negative 4, and the z is negative 1 minus a negative 5. Whenever we have two negative signs next to each other, it's going to be plus a positive. Okay, so I have a negative 12 plus a positive 4. So that means I'm going 4 directions, 4 steps towards the positive side. That gives me negative 8. And negative 1 plus 5 is going to give me 4 for my exponent. So I can rewrite this as negative 5, or not negative 5, 5 to the negative 1 power times x to the negative 8 power. I'm going to rearrange everything in a minute. Times z to the 4th power. Got rid of these because I combined them with the ones upstairs. And all I have left is y to the 7th power in the denominator. Okay, so now what I need to do is I have two negative exponents in the numerator. I need to move those down to the bottom so that they actually become positive exponents. So I say equal to, so all I'm left with is z to the 4th power over 5 to the 1 power, but you don't really need to write it because it's just the first power, times x to the 8th power times y to the 7th power. I think you can see that low in the video. I hope so. So that would be the final answer. Let me check with the book. Yay, it's right. Okay, so that's the final answer for that one. That explains the long, long step process. Okay, there's one more that I want to do. And that is on page 347, number 59. So we have 8a to the 16th power times b to the negative 2 power, I believe. Yes. Over 12 times a to the negative 9th power and b to the negative 4th power. So, we have three types of like terms. We have constant numbers or coefficients out here. We do have two a's and we do have two b's. We're going to use the quotient rule for these, and then we're just going to do regular reducing of a fraction here. So 8 over 12, that factors into, I'm going to work with piece by piece right now. That's 2 times 2 times 2, and 12 is 2 times 2 times 3. Whatever I had the same in the top and the bottom, I can cancel out, so that's 2 sets of 2s, so I'm left with 2/3. So I know that in my answer, I'm going to have at least 2/3. And something for A and B also. Now when we have A and B, well, we have two A's, one on top, one on bottom, and we both have exponents. We need to subtract those exponents to combine them. So we use quotient rule. We have A to the 16th. This one here, we're going to subtract these two numbers minus a negative 9. When we have the minus, minus, we do plus plus. Gives us A to the 25th power. That didn't come out very well. Okay, so we have A to the 25th power. Then we have B that we're going to work with. B to the negative 2 minus a negative 4. Plus a plus. When we have a positive 4 and a negative 2 combined, we're actually doing 4 minus 2. That gives us B to the 2nd power. So you can write it this way, or you can write it as such. So it probably doesn't look like much fun at first, but it doesn't come out too bad. So you can write it either way. Both ways are correct, because when it's combined like this, It's multiplication. Okay, so that's it for 5.1. We'll do 5.2 in next video.